recording this session because various folk have said to me that they can't make it. So I just need to have a recording to send on to them after this. So I think we're going. Just letting people through the lobby. So yeah, hopefully most people are here. If I can just start with an acknowledgement of the traditional owners of the country from where we're hosting this webinar, which, as I understand it, is the country of the Turrbal and Yugara nations, and the country from where Ida is presenting her webinar, which I understand to be Yuragunajay and Jabagay nation country. And I accept their relationship and connection to the land and water of the regions, and I pay my respects to the traditional owners and to the elders past, present and future. Today, we're going to hear a presentation from Ida Addicott with some support from Donna Lewis. At least that's what Ida says. She's going to call on Donna to actually help answer some questions at the end. And the work is on characterising Australian vegetation across state boundaries and globally. Ida is a principal botanist at the Queensland Herbarium, based at the Australian Tropical Herbarium, James Cook University campus in Cairns. And the talk she's giving today, which is called Eucalyptus tetrodonta on the world stage, is based on a talk she gave at the Ecological Society Association meeting back in 2021. So I welcome Ida, and thanks very much for presenting, and thanks to you all for tuning in today. Thanks, Ida.
Thanks, Jeff. Thanks, everyone, for tuning in. So, as Jeff said, you'll have to forgive me, I'm a bit nervous to start with, as always happens. As Jeff said, I'm based up at the Australian Tropical Herbarium up in Cairns, and today I'm presenting joint work done particularly with my NT colleague Donna Lewis, but it's a part of a body of work that's been published in this paper by Moldavan et al. In 2021. So just to give you context, underpinning all land management is the need to know what is out there. Veg classification systems are a tool for understanding the composition of plant communities in the landscape, and when they're mapped, their distribution. So given the national and global nature of threatening processes, it's increasingly important that an understanding of what we have and what the plant communities are composed of is consistent across state, national, and within a global context. So this talk is about work that contributes to that. So firstly, a bit of vegetation science history to put our work into a philosophical framework. The two most common ways of understanding the plant communities in our landscapes are firstly, or the one, by defining them based on their floristic composition, and then seeing what those differences tell us about the environmental variables underpinning their niches where they occur. And the second way, most common way, is to define the niches in the landscape identified by different environmental variables and then describe what plant communities occur in them. The first assumes that different plant communities indicate different environmental variables, and the second comes at it from the other way, that the different niches created by environmental variables will tell us what plant communities there are. Broadly speaking, the first method came out of European scientific tradition, and the second from the Anglo-scientific tradition. In Australia, there was some early work towards floristic-based vegetation classification for our veg. So that's, for example, that's beard, beetle and spect. But in Australia, scientists have generally adopted the latter approach, an ecological and functional-based approach to classification. And until lately, there's been very little effort to relate our vegetation types to those found elsewhere around the world. So there's a couple of reasons for this. First, the biggest one is probably because there were, and still are really, very few vegetation scientists per square kilometre in Australia, and our flora has been largely unknown. And there's always also been some argument that because Australia's flora is so unique, the global classifications that have existed to date weren't really that applicable. However, as I mentioned, with ecosystem threatening processes now being regional and global as well as local, it's become imperative that we understand our veg systems, Australian veg systems in this global context. So there has been a few attempts at developing global veg classification systems. One of the most recent is the International Vegetation Classification System, or the IVC, which has been applied across a number of continents to date. Oh, yeah.
You're right, Ida, we've lost your microphone.
Have you? Okay, so is that better?
Yep.
Can you hear? Okay,
Yep.
Sorry. So what is the IVC hierarchy? It's a vegetation classification system based on a combination of the two approaches that I just outlined. It's based on macroecological drivers at the upper level, so that's at the global to continental levels, and on plot-based floristic data and quantitative analytical methods at the mid and lower levels, so subcontinental levels down to plant community level. It includes both natural and cultural vegetation types and has a separate hierarchy for each of those. And its aim is to provide a system that can be used to assess ecosystem changes at a local and global level. So for natural vegetation types, there's an 8-level hierarchy. The 3 upper levels, or formation types, so these ones up here, are based on general growth forms and global ecological drivers. The 3 mid-levels are based on physiognomic, phytogeographic and floristic information, and the 2 lower levels are based on full floristic information. The classification approach, which underpins the hierarchy, is named the Eco-Veg approach, and this specifies using the best available data sets, having preferred plot size ranges from 0.01 to 1 hectare, and the data also needs to include full species lists by strata with cover values, and that's % canopy cover, or crown cover, I should say, and also needs to have supporting environmental and site information. It requires the characterisation of vegetation elements in the hierarchy to be based on plot-based quantitative analysis at the mid and lower levels. And a particular characteristic of the IVC is that it requires the development of the classification system to be coordinated among work groups and stakeholders to optimise its implementation. Let's see if this works. Is that going to work? You can still hear me? Yep. Okay.
Yeah, all
so
good.
It's all okay, great. It's all well and good to talk about theory and ideas of these classification systems, but I thought I'd show you what it looks like for real. Yep, that's worked good. The IVC is developed to its greatest depth in Canada and the US, and to a lesser extent in the South Americas and Africa. So you can see here the upper or formation levels. The first divide of formation class is physiognomic, so forest and woodland. Then climate comes in the form of latitude to give the formation subclass tropical. And then wet versus dry to give the formation of tropical dry forest and woodlands. In the mid-levels, we introduce the divides along biogeographic continental lines to form divisions, so the Caribbean, Mesoamerican. The macro group level incorporates mesoscale of ecological drivers to delineate Caribbean coastal lowlands. And then the mesophysiognomic information that comes in at the group level to give evergreen forests. So this example is a work in progress, because you can see in the lower levels of the hierarchy, there's no alliance level, and it jumps straight to the community level or plant association level of Acacia macrantha, Bachellia phoeniciana shrubland. And this will have been incorporated from an existing quantitatively derived unit for a project that's been done at a local scale. So, as a step towards testing whether this IVC hierarchy might be a suitable framework for use in Australia, we asked, can the uniquely Australian Eucalyptus tetrodonta woodlands that occur in Northern Australia be incorporated into a global IVC hierarchy to give them both a national and international context? So Eucalyptus tetrodonta is one of the many eucs endemic to Australia, which is probably didn't need to say that. It's a common and dominant tree across Northern Australia, and the woodlands cover an area of about 253,000 square kilometres. They extend from across the whole continent from east to west, and from Torres Strait Islands in the north to about 19 degrees south, which is around about Charles Towers. They range across the humid to subhumid tropic zone with a wet dry season, and most of the 1,000 to 2,000 millimetres of rain falls between December and April. They range in height from 10 to 30 plus metres, from open woodland to forests, and have varying codominant species. They most commonly occur on sandstone plateaus and sand plains, less commonly on granite mountains, and they grow from sea level up to about 800 metres. So we extracted site data from the NT database, the NTSVD, and what is now the QBIS database that is in Queensland. So both of these databases are central repositories for veg plot data in those states. Unfortunately, we didn't have any WA data because it doesn't have a central database repository at the moment, and we couldn't get hold of any individual data sets within the time frame for this work. Our extraction methods differed between the two databases in the two states. From the NT, we took out all the plots where tetrodonta was more than 3% of the canopy cover. And in Queensland, we extracted all the plots which had been allocated to vegetation types described as having tetrodonta as dominant or co-dominant in the canopy layer. Any taxa that weren't consistently identified to species level, we amalgamated up to a genus level. We removed ecotonal plots using expert knowledge based on structure and floristic composition. We removed sparse species from the dataset to reduce the noise by removing species which contributed less than 1% to the total canopy cover. We summed the species cover across strata in each plot to give a total cover for each species. So we ended up with 859 plots with 767 species from Queensland and the NT. We used Primer E software and calculated the dissimilarity between each plot with the Bray-Curtis coefficient. We used hierarchical agglomerative clustering to produce a dendrogram which shows clusters which are significantly different to each other. We identified vegetation types at the 4 cluster and 6 cluster levels and produced characterising and diagnostic species for each of these. So once we had our vegetation types, or clusters, we then allocated these into the IVC hierarchy using a key and brief descriptions to the IVC formations that have been published in a paper titled Classification and Description of World Formation Types. We used criteria that has been published outlining the standards for associations and alliances within the IVC. We used unpublished draft collations of the IVC divisions of the world. We used expert knowledge with reference to environmental data sets such as geology, soils and rainfall. And we also referred back to existing subcontinental veg classification systems just to test whether what we were picking up had been found in the field. After this, we crosswalked, after putting these into some IVC context, we crosswalked our results to existing national, state and territory classification systems. And all of these systems have been qualitatively derived. At a national national context, national comparisons, we're talking about one's classification systems that exist across or that cover the whole of the Northern Australia. So there were 3 of these that we crosswalked to. Vegetation of the Australian Tropical Savannas by Fox et al. 2001, which is a combined substrate and floristic classification system. We crosswalked to Beadle's 1981 Vegetation of Australia, and that's a purely floristic classification. And we crosswalked to the major vegetation groups and subgroups within NVIS, which is a combined physiognomic floristic sort of system, but it's specifically designed for mapping. At the state levels, we classified, or we crosswalked to classification systems. For Queensland, we used the Broad Vegetations of Queensland by Nelner et al., which is a combined substrate, climate and floristic system. For the NT, we crosswalked to their different levels of the ENVIS system that they use. For WA, we crosswalked to two systems. Firstly, the land systems, which is a substrate landform dominant species based classification. And we crosswalked to the 1 to 3 million vegetation types in the vegetation of West Australia by Baird et al. 2013. So we found in the clustering, it started off by producing two distinct woodlands at the lowest level of similarity, one of which was a Melaleuca leucodendra woodland, and so we haven't considered that any further. The tetrodonta, or the woodlands that contained tetrodonta or were dominated by tetrodonta, then split into two as well. One which was a Corymbia ferruginea Eucalyptus tectifica woodland, and this has been recognised by Beadle as well. But the tetrodonta within these woodlands tend to be ecotonal species and not a diagnostic species. So those woodlands are not. We haven't considered those as part of our study. So we focused on these woodlands, which are basically dominated by tetrodonta. So within these woodlands, it's split nicely into two groups, a tetrodonta Eucalyptus miniata group and a tetrodonta Corymbia bloodwood group, so tetrodonta Corymbia species group. Each of these then split into two. So the tetrodonta miniata group split into tetrodonta miniata Heteropogon triticus, or giant speargrass cluster, and the other one was a tetrodonta chrysopogon triodia cluster. The tetrodonta bloodwoods split into two, tetrodonta Nosophilus stockeri group or cluster, and the second one was Eucalyptus chartabomma Corymbia pusillum Eucalyptus tetrodonta cluster. When we look at a map of the distribution of these plots in each of the clusters, you can see a nice east-west divide, with the green dots representing the tetrodonta miniata cluster and the blue dots representing the tetrodonta Corymbia species cluster. This is a nice biogeographical divide between a Precambrian shield in the west and the Mesozoic sandstones in the east, and the clay plains of the Gulf Plains in between. The different shades of blue and green represent the two different clusters within each of these major divisions, the lighter blue being the tetrodonta Nosophilus stockeri group or cluster, the darker blue being Eucalyptus chartabomma pusillum Corymbia pusillum cluster. The lighter green represents the tetrodonta miniata cluster, and the darker green is the tetrodonta with chrysopogon and triodia cluster. So for those who might be familiar with the tetrodonta woodlands in both the states, what was interesting was that the tetrodonta Nosophila woodlands in Queensland didn't group with the tetrodonta Nosophila woodlands in the NT. And that we sort of went, oh God, what's going on? And so we really looked into it. And what we found was that the NT woodlands are containing Eucalyptus miniata even as well. And that's a taxon which just doesn't occur in Queensland. So that's why they weren't grouped together. So all four of these clusters have been recognised at some level by previous qualitative studies. So at least we know that people have actually found these things in the field. So when we cast these clusters into the IVC hierarchy, we find that the savannas in general are included in the shrub and herb vegetation formation class at the very highest level. And that's because savannas at a global scale are predominantly identified and dominated by grasslands, and currently the treed savannas are included within this. Below that is our clusters fit into the tropical savannas formation subclass and the tropical lowland savanna formations. It was at the mid-level of the hierarchy that the Australian vegetation becomes unique, with the division of Australian tropical savannas and scleromorphic woodlands. So before this study was done, this division had been titled Australian tropical savanna, but because of these treed savannas that we've found with the tetrodonta woodlands, the IVC name has been updated to include scleromorphic woodlands. However, there's some ecologists in Australia that aren't really comfortable about having our treed savannas incorporated under a shrub and herb formation class. As you might imagine, there is a global review of the categories within the IVC being undertaken currently, and the panel includes representatives from Australia. So the tetrodonta woodlands in toto fitted into the hierarchy at this mid-level macro group, which is where they became unique. A macro group means that there's some dozens of sets of diagnostic species and some strong differential character species. There's a subcontinental mesoclimate, which is indicative of regional gradients such as latitude, altitude, or broad geological formations. So in this case, that's tropical, and it's sandstones and sand plains. There's a subcontinental natural disturbance variable, which is fire in this case. This macro group has now been formally recognised into the IVC hierarchy with a full description and supporting documentation. So the clusters on the either side of the east-west divide are still in the mid-levels of the hierarchy at this group level, and they've got a narrow set of diagnostic and constant species, and they've been differentiated by that subcontinental scale geological divide of the Western Precambrian shield and the Eastern Mesozoic sandstones. The two clusters within each group dropped into the lowest part of the more detailed level of the hierarchy, sitting as an alliances. There's obviously more work to be done to identify the associations within these alliances. However, there is starting to be quite a bit of thinking in other parts of the world that this alliance level of classification is actually most useful for land management purposes. So importantly, our results from this study fed back into the IVC, and the hierarchy has been updated and adapted to include our findings. And this will continue as more work is done. So we've got our levels of groups and cluster types, vegetation types within the IVC hierarchy. The next thing was to test whether the hierarchy might be useful for from a national cross-jurisdictional point of view. So we crosswalked these, as I mentioned, we crosswalked them into existing national and state veg classification systems. So at the national level, I've mentioned this earlier, the systems which cover Northern Australia were the Vegetation of Australia by Beadle, the major veg groups and subgroups of the ENVIS, and the Vegetation of Tropical Savannas by Fox et al. At the state level, just to reiterate, we used two from WA, the Land Systems Classification and the Baird 1 to 3 million vegetation types. The NT, we used the ENVIS hierarchy that they've adopted, and for Queensland we crosswalked to the broad vegetation groups by Neldner et al. As you can see, and to use robust scientific terminology, it's a bit of a hodgepodge. At the division level, which is where the Australian tropical savanna and scleromorphic woodlands, there were 3 major vegetation groups and 4 major vegetation subgroups from ENVIS that could relate to this to this divisional level of our hierarchy. The NT, there's 2 formations from Beadle, and no mention in Fox et al. At this level of the hierarchy. From a state jurisdiction point of view, the NT has 2 broad floristic formations that relate to this division, and WA has 2 vegetation types from Beard. Queensland has no equivalents in the BVGs to this division level. At the macro group level, so the group at which tetrodonta woodlands become uniquely global and nationally, there's 1 equivalence of what Beadle calls an alliance and 1 broad vegetation group within Fox et al. There's no equivalent MVGs or major vegetation subgroups from NVIS. From a state jurisdictional perspective, there's none which relate to the equivalents of these macro groups. At a group level, the NVIS and the NVIS major vegetation groups and subgroups are too broad a scale to be really comparable. So we jump to the subformations within the NVIS hierarchy, and there's 8 which could relate or do relate to these 2 groups. There are 2 sub-alliances in beetle and part of 1 alliance in Fox et al. From a state point of view, Queensland has 2 1 to 1 million scale BVGs that relate to these 2 groups and part of 1 to 2 million scale BVG. The NT has 8 subformations that relate to the groups. WA does not have any that relate to these group levels. Dropping to the alliance level, there are 8 alliances from NVIS and 8 in Fox et al. That are equivalent at the sort of Northern Australian level. Some of the 8 alliances in Fox are very similar floristically, but divided based on substrate. From the state perspective, the NT has 8 alliances from within their NVIS system, and WA has 14 land units across 6 of the land systems, which could relate to which do relate to the 4 alliances. There's no equivalence within Queensland BVGs, and that's because the scale, the alliance level is below the scale of the BVGs. So although each state has the plant association as a fundamental veg classification unit, they're all been lumped up very differently. And this means that there's no equivalent in any state to the IVC hierarchy level of macro group. So this in part reflects the different scales of management used in each state, but importantly, it spotlights the lack of cross-border relationship between floristic-based veg types in each state. So it really means that there's no robust way of equating vegetation types across state borders. And the question arises is, how are we really to manage things at a national cross-state level if we're not really sure and not really clear about what we have? So this crosswalking exercise proved useful for 2 reasons. Firstly, it clarifies those mixed relationships between classification systems in each state. And secondly, it shows that national floristic classification could be useful and demonstrates that an umbrella framework can help tie the disparate systems together. So an obvious question to arise from this work, I guess, is what do we think might have happened if we'd included some data from WA in our classification exercise? So I personally don't have any experience with the tetrodonta woodlands in WA, but based on the descriptions given in the land systems documents, there looks like there might be a couple of more types that we might have found. One was the Eucalyptus tetrodonta corymbia opaca woodlands from the Baldiva land system, although it's possible that this may be congruent with a macro group, suggested macro group that's been found in later work done in the NT. The other is possibly a type that includes Eucalyptus phoenicia, but given that Eucalyptus phoenicia also grows in the NT in Queensland, it may be found to be equivalent to a completely different, more widespread unit. Oops, wrong way, sorry. So in answer to our original question, can the Eucalyptus tetrodonta woodlands of Northern Australia be incorporated into a global IVC hierarchy? Well, we reckon yes, they can. And we show here that the developing IVC hierarchy is flexible enough to accommodate uniquely Australian veg types. It's based on quantitative plot-based floristic analysis. It has a rigorous set of classification concepts and protocols, and it allows comparison of vegetation types across state boundaries and puts our vegetation into a global context. So what about mapping? Veg mapping is a fundamental pillar of land management in Australia, so the IVC really needs to be considered with an eye to its applicability to veg mapping applications. To consider this, I can really only draw on examples provided in our paper, which come from the US, because there's no Australian examples at the moment. In the US, the framework has been used to guide the development of map legends for all the national parks in the country. and has also been used to produce comprehensive maps of ecosystems, generally at the group and alliance level. In these instances, the IVC has been used to provide really detailed descriptions of the vegetation types, while for mapping purposes, they've been grouped up to match the map scales and the image resolutions of the individual projects. And, you know, this is just a wild thought bubble, but possibly the IVC hierarchy could be mapped using the structural map-oriented NVIS that we've already got in widespread use. Just an idea. So, the major conclusions from our work. It really highlights the extent of siloisation, great word, between states with respect to veg classification systems, and the need for a national floristic-based classification system that can give us a bit of a perspective on our veg types. We see an Australian National Vegetation Classification System as complementary to the existing NVIS, which is a physiognomic mapping-based system. And we propose that the IVC hierarchy is a useful framework for forming this Australian National Vegetation Classification System. So you may remember from one of the earlier slides, one particular characteristic of the IVC requires the development of this classification system to be coordinated among work groups and stakeholders so that to optimise its implementation, basically. To this end, a group of veg scientists have started a research chapter under the umbrella of the Ecological Society of Australia, and that's the Australian Vegetation Classification Research Chapter. The main aim of the group is to develop division and macro group levels of vegetation types for Australia and to promote the exchange of ideas and information between people and groups working in this veg classification space. And finally, the research chapter is also associated with the International Association of Vegetation Science, whose focus is the theoretical and practical studies of vegetation in all its guises. So the composition and structure, the history of vegetation, the distribution, the classification, its management and uses and dynamics. They're essentially a European-based association. They've got members from all over the world now, and they meet annually at an annual conference with alternate years in Europe and outside of Europe. So next year, their conference is outside of Europe, and it's in Coffs Harbour in September. So I'd really encourage anyone who's with interest in vegetation science to put it into their calendars and consider attending. It's a great opportunity to see what's happening in the rest of the world and to show the Northern Hemisphere scientists what's happening in Australia. And it's also a really great opportunity to develop new collaborations and connections. For example, this project was born at one. Okay, thanks very much for your time. Thanks very much for listening. And I'll look forward to any questions, and any questions I can't answer, I'll call on Donna to give me a hand. So thanks very much.
Thank you, Ida. That was great. If anyone's got a question, you can either put your hand up and hopefully we can unmute your microphone, or you could pop it in the chat and I can read it out. But yeah, I'd welcome any questions at this point in time. Everyone's digesting it, Ida. Your mic's off. Hope that wasn't swearing.
No, it wasn't, fortunately. Yeah. Yeah, there's a bit in it to think about.
Just to let those people know who joined somewhat late in the proceedings, there is a recording which I can provide access to. Donna, is there anything you'd like to say at this point in time, or?
I guess the only thing I can add is that Ida's done a brilliant job of presenting this, and
I agree.
I think it was a great way to highlight the need for a floristic-based classification that's cross-jurisdictional. So following this work that Ida did, and obviously I provided the NT plot data, we actually undertook an analysis for the whole of the Northern Territory, actually, at the macro group level. So that's recently been published, previous to the paper Ida was talking about with the tetrodonta woodlands. So we've actually identified 21 macro groups in the Territory. So currently working on another paper with Ida to crosswalk the macro groups to the Queensland BBGs and to the South Australian classification, and also NVIS and the global IUCN ecosystem types too. So we're hoping that that might be another potential presentation that people would be interested in. And maybe even a savanna biome macro group classification as well, or any other biome that that we can get some data, top data for, to do the analysis.
Thanks, Donna. There's a question from John Nelner, wondering whether or not using total cover, adding the total species cover across layers might potentially overemphasize or emphasize the grass instead of the trees. John, is that's sort of what your question's asking, isn't it? It doesn't. No, it doesn't. So by adding the tree, like if you've got the same species in the T1 and the T2 and the S or the S1, if you add those layers, add the cover together, it doesn't add up to 100% anymore, but that doesn't matter. It helps to emphasize those tree layers over the grass layers. But apart from that, we haven't found that to be the case. We don't end up getting, grasslands that are dominated by tetrodonta coming out as grasslands. Does that answer the question?
I'm not 100%. People can unmute their microphones, Ida, so
right.
Hang on. Oh no,
Okay.
John's unmuted. John?
Yeah.
I think it's more the other way, Ida, that 40% Heteropogon triticus gets treated the same as 40% tetrodonta in terms of importance, and obviously there's a clear biomass difference in that. That's just what my brain's been thinking about in terms of that, because they would get equated as equal weighting, whereas there's clearly a significant biomass difference between that scenario. And otherwise, also I was wondering whether you might end up with tetrodontas around 60 or 70% if you've got a very shrubby fire stimulated shrub layer as well as an intact canopy. So that was just my concerns about cumulatively adding across layers.
So a couple of points. It's a floristic classification, not a biomass oriented application classification. So it's not. So Queensland, as you know, Queensland has an emphasis on the ecologically dominant layer, which is that layer with the highest biomass. But a floristic classification doesn't necessarily have that. It just treats everything as equally important. So that's the difference between the two. But look, I was expecting that to happen, but it hasn't. So there you go. There's obviously enough tetrodonta in those woodlands to keep them as tetrodonta woodlands and not come out as grasslands. Yeah, that's as far as I can go with answering that question. Sorry, Arnon, there was one. Is there any funds allocated to other states to improve their mapping to align with Queensland? I've no idea, Arnon. Sorry, that's an NVIS question, really. Donna might have more idea.
So if we're actually considering to use NVIS, unless southern states got the funding to upgrade the mapping, we always will have the problem that we had 20 years ago.
Well, I guess you've got to put the ideas out there and see if they
Yep.
can fly, basically.
But without fundings, they won't fly. Queensland had the fundings for vegetation management to
But you've got to
support.
start, I guess, yes, that's true, but you've got to start with the ideas.
Anyway, I just thought
Anyway,
that's important
so,
part of the equation.
Yeah.
I guess I can add a little bit more to that, but yeah, great point that it does need to be funded probably from the Commonwealth level, I guess. But there was a road mapping exercise towards the end of last financial year for NDIS, and it was called Dynamic NDIS. But I'm not sure if that's been picked up again. I don't think the road mapping exercise was completed. So I guess with the change of Commonwealth government, we'll be watching this space, I guess. And like Eva said, you know, putting some ideas out there. I know there was some interest at that point of incorporating block-based information into NDIS to make it a more dynamic product.
Thanks, Donna.
Thank you.
Yeah, I think when you start asking interesting questions and show up interesting classifications like this, then I don't know, it generates funding, doesn't it? Or can generate funding.
Well, yes, at least it gives you some basis to say, well, you know, we need to think about getting this fixed, and to do that we need funding, I guess.
Yeah.
Yeah.
So do we have anyone else as a last minute question? Not that it's last minute because we've got 20 minutes until 1 o'clock, but can't force people to ask a question. I think it's been a very interesting talk. Thanks, Ida, and I appreciate you overcoming your nervousness to present, because I think we've all been given something to really have a think about. And I have provided, oh no, if anyone wants to contact me because they didn't see the whole thing and they want a recording, please do. If you need to contact Ida directly, then I assume you're ida.addicott@des.qld.gov.au.
Yep.
It's the usual email. And yeah, the accolade, the thankses and so on are coming in now, Ida, and I think many people appreciated the talk. Next,
Guys, thanks,
yep.
guys.
Okay, and next month, well, we've got 2 months worth of webinars to go, and amazingly, we've got 4 webinars to fit in. But the next one is the 10th of October in 2 weeks' time, and it'll be by Stephen Trent. I haven't actually checked with Stephen, but I assume he's still fine to do this. He's from the Biodiversity Assessment team, and he's presenting on an application of a mixed habitat suitability modelling method to inform legislative mapping for Queensland's threatened species. So if you'd like to join in that one, I'll be sending around the invite fairly shortly. Thanks very much for attending, everyone. I appreciate it, and we'll see you in the future. Thank you.